We also have another option. It is called DHCPv6 and it is similar to DHCP for IPv4. It is a stateful alternative to Slack. Stateful means we can track the state. Somebody has a table listing all the IP addresses that are used on this link that have been handed out by DHCP. DHCPv6 is also used to provide Slack hosts with additional information that is not provided by Slack, such as DNS servers. We have an RFC 6106 for announcing DNS servers with the router advertisement, but this is mostly not implemented, so you cannot rely on it. So in most cases, people that use Slack in their networks, if you have a corporate network and you have a client VLAN for, let's say, marketing, then you announce the marketing prefix, you announce your router, but you cannot announce the DNS server. To fix that, you can set a specific flag in the router advertisement that means, here, please check DHCP additionally. And then you can do a DHCPv6 request, just requesting the DNS servers and not the IP address, because you already configured that using Slack. DHCPv6 can also be used for IPv6 prefix delegation, which is used with DSL routers if your provider supports it and you get your own network behind your router. This is used in cases where you don't only have your IP address, your public one, but you also have your own network to be routed to the inside. Let's have a look at the specifics of DHCPv6. It uses UDP port 546 for the client and 547 for the server. There is a DHCP unique identifier, DUID, which is sent by the client to request an address. You can set static addresses on the DHCP server, just like in IPv4, not using the MAC address, but in this case using the unique identifier, so you can make reservations. The DUID is checked with the DHCPv6 database of the server if there is a static mapping, or maybe there is a lease that's already active, then the same address is handed out again. And the address is then announced by the DHCP server. Like I told you, you don't have to get an IPv6 address, you can also just use the DNS information. This is the whole process of DHCPv6. Let's have a look at the steps used with DHCPv6 if you're not doing Slack, but you're also getting an IP address from the DHCP. Your client will boot up, generate a link local address like discussed, and then it will send a solicit message to the multicast group all DHCP servers. All the DHCP servers will reply with an advertise message sourced from the link local address to the link local address of the client. Then the client will check this and will reply with a request for this assigned address, again sourced from the link local address, back to the multicast group all DHCP servers. And then the final step is the DHCP server will send an assignment of the address from its link local address to the link local address of the client. Then again, the client does a DAD, and if it gets back no reply, so the address is unique, it can be used. Here are two examples of DHCPv6 configuration on Cisco. It's not that hard, but we will not talk about it in detail. You can just try it out if you like in a lab. For troubleshooting DHCPv6, I show you two commands that you can use. The first one, displaying the DHCP pool, all allocated addresses, and the second one is showing the DHCP bindings, which is addresses that have been allocated to clients. We have another example, show IPv6 DHCP interface, which shows additional information. And because we are vendor independent, I will also show you an example configuration of the ISC DHCPd6. That's the open source version. It is also not that hard. Have a look at it, try it out in a lab, and play with it. The second example is a configuration of a Debian Linux client. See, it's really easy. You just have to type inet6 DHCP. That's it. Then your client will do DHCP.